Dear students, in this video we will study about the purpose of control systems. So here I have installed MATLAB R2009B version. So let's open it. So MATLAB is actually called Matrix Laboratory. Okay, it's a language of technical computing. So all the engineering approach can be solved in MATLAB platform. Okay, so when you open the MATLAB platform, you can see this is called command window. Okay, that means whatever the program or single line program, or you want to make dry run, means write one line, run one line, so you can do in the command window. Then once you given some value to a variable, those value will be saved in the workspace. Okay, and you can see what the command history in the command history window. So this is the programming kind of thing. But what we study today will go for simulation. That means some blocks, some programs are made in terms of blocks, and we just drag and drop those blocks to use for our applications. Okay, so for that, at least you should go for a file, a new, then a blank files or model, or just click here in the Simulink. Okay, so to do that, go for Simulink here. It is a Simulink here. Once you create Simulink, okay, once you open the Simulink, then there will be a window looking like this will come out in front of your screen. And here what you do is just go to file and click new the model, or just press Ctrl N, another pop-up window will open, or simply click here so that another window will open. So before doing that, I'll show you something. In the left side we have having many numbers of libraries. So Simulink library, aerospace, then communication, then control systems, fuzzy logic, image, instrumentation, model, and radio frequency, real-time workspace, many more things are there. Okay, so what we need will find here. Let's say if you want to go for if you want to find a transfer function model, you just click here, then go to continuous, then you will find a transfer function here. This is the transfer function. Okay, so now I want to show you the test signal. Okay, so as we know that we have some text signal like step signal, then impulse signal, then ramp signal, and parabolic signal. So that I want to demonstrate, and how to get one signal from another signal, that I also demonstrate to you. Okay, so once I open this, let me make it small size so that it will be easy to understand. Okay, and once you click here, you will get another open window open, that is the thing about the untitled, that no you, the model name is untitled name. So what you want to do now, so here you just without actually finding out, or without searching where it is there, you directly click here and search what you want. I want a step signal, STEP. So after typing step, if you hit enter, it will search where the step signal, and here step signal coming out. So once you click step signal, it is showing that the library is Simulink slash source. Okay, that means in the library Simulink, if you go for source and click here in the source signal, you can find the step signal. So once you find the step signal, left click and drag, left click, hold the click and drag to the new model. So this is the way to take a signal or take a block from the Simulink library to the untitled workplace. Otherwise, what you do, you just click in the block, right click in the block, then add to untitled. Okay, or you can go for shortcut, that is Control I, so that it will appear here. Okay, But now I do not want two things. I just want only one scope. So I just delete one scope, right? Sorry, not scope, it is my step signal. Now it is important thing. I want uh, a ramp signal. So ramp is here, or you can search ramp here and you can drag it. So this is my ramp signal. Okay, let me check out what are the signals available here. You can see the known signal, what you know. This is a rectangle signal or pulse signal. If you go for more, you can see uh, a sine wave is there. Okay, these are the signals what we have already existed. And so what you see, let me actually zoom this thing out so that it will be visible to you. So these are my signals: step signal, ramp signal. One is pulse generator, which actually produce the our rectangle signals, and have sine wave. Okay, how to find out which signal is actually doing things? So I need a scope. Okay, what is scope? We have seen in library that in laboratory we have seen oscilloscope. That means you can observe the waveform. So here oscilloscope, inside you can say scope only. So you just type scope and hit enter. You'll find out a scope which actually present in the commonly used block here. Simulink commonly used block. So you just drag it out here. Okay. So once you do this, okay, for each step and for each block or for each signal, I need separate scope. So similarly, I have to go to the library and drag one by one. Otherwise, what can I do? We just right click here and then copy, then right click somewhere else and paste. I am getting another things, two signal. Or you can select Control C and Control V, that also work. One more technique is there. Once you select it, instead of putting left click, you just put right click and drag, it will copy. So likewise you can do this. So once you do these things, then here it is output. The arrow out is output, arrow in is input. You just once you can see when I take the pointer to the arrow point, the pointer is converting to cross sign or plus sign. So once you get a plus sign, left click and drag to the next point and release the click, you will get these two blocks are connected. Once these two blocks are connected, they will be connected with a black dark line. If it is not like this, if it is like this, that means it is not connected, so it will show a red line. Okay, clear? So what you do now, you just delete this red line, again click here and join. Likewise, you can join these two blocks or you can join many more blocks. Okay, so once you join, what you want to do? I want to run, I want to simulate. Scope is nothing but a digital graph sheet where we have x-axis and y-axis. Here I want to find what is the length of x-axis. That I can do here. That means I want to run my simulation. Here it is 10.0 means 10 seconds. If I run my simulation for 10 seconds, then I can see my graph, the plot will be extend from 0 to 10 in x-axis. So once you place the value 10 or 11 or 15, whatever you want to do, give this value, then go to this button that is called start simulation and click here, left click. Once you click, there will be round symbol here and you will hear a sound, beep sound. Then it was showing that you understand that this round is already over. Then once you go to scope and here you double click the scope. Okay, once you double click the scope, you can see there is step signal. It starts from 0 and take a step to 1, then constant. If you make it large, you can see it is a unit step signal. It starts from 0 and after delay of 1 second, it step to 1 and remain continuous to the step of 1. You can say, sir, what is after this graph? That also can be seen. How can you see? Instead of 10, you just write 100 and run. So once you do this, again you open this, you can see it is also showing 10 because it previously data stored. What you do, you just click here. It is called auto scale. Once you click here, you can find out the x-axis data is 100. Okay, and you can see here from 0 it was starting and going to 1. Okay, here it is 10 na? So going to 1, they can take a step to 1 and remain 1. So if it is not visible to you, what you do, you right click here, go to axis property, then here you can see y minimum value, it is showing -5 and y maximum value it is 5, and click apply. So once you do that, the graph is clearly shown. Starting from 0, somewhere to 1, it take a value of 1, then remain constant as 1. That is a step signal. It take a one step ahead. Okay. Similarly, if you see ramp signal, you just one all things are connected in a single window. So when you run, all things will run together, and you just open it and you will see a ramp like structure is there. Or if you go for auto scale, you can clearly see this is a ramp signal. Clear? Something passing through origin. Similarly, if you want to see the pulse, open the scope and you can see these are the pulse signal or rectangle pulse. Small pulse are there. You can change the width also. And for sine wave, if you open this, you can see a destruction of version of sine wave are there, because you want to, because some auto scaling has not been done. Here once you make auto scale, you can get a pure sine wave. Okay, it starts from 0, go to 1, then come back to -1, then to 0, then 1 likewise. Okay, so these are the things. Now you can say how to change the step signal from one unit step to some other to value 2, 3, 4, whatever. So you just click in the step, then a box will open out, then you can set here the step time. What is step time here? The delay time. You can see now it starts from 0, then when it reaches 1, it will take a step. So if you make it 0.5, that means if you make it 0.5, then before reaching to 1, it actually step out. And initial value have given 0 and final gap value given 1, that means unit step. Here instead of 1 I am giving 5, then click OK. And then after making run, you open the scope and go to auto scale, then you can see it starts from 0 and it reaches to 0.5, then take a step reaches 5, or you go to the axis property, then click apply, and it is very clear. Or if you make instead of 5, you can make 6, so that my axis range will increases. I can see it starts from 0, go to 0.5, then it reaches to 5, then continue. Okay, similarly, if you see the ramp signal, click here and you can change the slope here. It is slope is 1 and your starting time is 0 and initial output is 0. So it starts from 0 and output also 0 and take a slope 2, take a slope of 1. So if you make your initial output as 1, it starts from 1. You can see here, once you click and open and go to auto scale, then you can see instead of previously it was showing 0 0. Okay, or you can write just go to axis property and now click apply. You can see here instead of starting from 0 in x, instead of starting from here, it actually starts from +1. Okay, so this is my what? Ramp signal. Similarly, you can change the pulse here. What is given? Amplitude is 1. Pulse period. What is pulse period? The repetitions. And pulse width here is 5%. You just make 50%. So that you will get a on and off cycle like this. Clear? Like this we are getting. So here just instead of making 10, period is like you just make the period as 1. Okay, that is 1 means 1 second time period. Once you open this, you can see clearly visible. Go to axis property, then make +5 -5. Clear, you can see the clear signal. Okay, then if you go for sine wave, here if you click the sine wave and you see the amplitude and frequency. Okay, here frequency is radian per second. Okay, what you do, you just go for sample based, or you can make time based, whatever you want. Time based is actually perfect thing. And if you go for amplitude as 5, then amplitude becomes 5. Then if you want to go for 50 hertz, what is the 50 hertz? 50 hertz means you have to convert this 50 hertz into radian per second, 2 pi f. Then you put a value here, then you can see the value. I mean, you can see the perfect sine signal. So once you click here and click run, then you can see after auto run, you can see starts from 0. Instead of going 1, it actually go to 5 because I am giving the amplitude 5. So this is nothing but my sine wave. So here I just want to show you some basic tricks. So here when I click here, one graph open, I mean one scope open. When I open here, another scope open likewise. But if I want to show all this waveform in a single scope, what I do, I just remove all this scope and take a single scope here. Okay, single scope, and click the scope. Here what you do, go to this place. Okay, once you click here, number of axes you're asking, here you just make, instead of 1, you just write 4 axes and apply here. So once you make 4 axes, 4 different graphs will be generated. Then close it and little bit drag from the corners. You can see 4 inputs are there, and join these input from one to another likewise. Okay, once you join these things, then you can run this thing, and after running, if you click here, you can see after auto run, you can see these are the signals. This is step signal. Okay, what you do, the step you make it as 1 and run it. You can see the steps like this to scale. So you can see the step. This is a step signal. This is my ramp signal. This is my waveform, square wave. This is my sine wave. Okay. So now another things are there. Sir, from a single window you have shown 4 different graphs. Is it possible to create a single graph and overlap all those waveforms? Yes, that also can be done. How to do? What you do, you just remove all this line first. Okay, and I need only one graph. So what you do, instead of 4, you just make 1. Okay, and apply. You get one graph here, then close it. Then go to the Simulink. Here directly you can go to Simulink, or previously open Simulink here. You can find, you need to find a Simulink library, or else you just click here so that you can get a Simulink library immediately after clicking. Okay, so once you click here, just search that MUX, MUX. MUX means multiplexer. Okay, in digital logic circuit or digital electronics, you will study about the multiplexer. Multiplexer means it is switch having many input but one output. And demultiplexer is the opposite of that, it having one input but multiple number of output. So what you need, we need a mux. You just drag it out here and take the mux here. Now you can see output is matching as 1. I need one output, right? But I need 4 input. Here it is having 2 input. So just click here, and here number of input you make it 4, and okay. So we'll get 4 different input. Okay, so once make 4 different input, and if you drag all this thing together to the mux, or you can say the multiplexer, and now you just run this thing, and you open the scope, you can find all these are coming together. You can see the yellow line is the constant line step signal, the green line is the the square wave, and this line is the ramp signal, and we have a red line is called as sinusoidal waveform. Clear? So this is all about the signal, how to visualize the signals. Now what you do, you just, okay, let's say I am having a step signal. Okay, let's say I am having a step signal, and we just play something here, and what do you do, I want to integrate this step signal. Okay, as we know that after integrating the step signal, I am getting a ramp signal. Okay, that is the theory kind of thing. But how to visualize? You just click here the Simulink and search integrator. Why do you search integrator and hit enter? You will get integrator as written 1 by s in the block. So this is the integration in Laplace domain. Okay, so when you drag it out here, and what you do, you connect these two blocks, right? After connecting these two blocks, okay, you just run these things, and you open this scope, you can find out, you'll get a ramp signal. It starts from 0.5. Why from 0.5? Because my step signal starts from 0.5 here. Okay, okay, what you do, I want to see this thing in a single scope. You just make as 2 input. Once you make 2 input, okay, and what you do, you will get, let's say I'll put my input as my this one, and output here, and I run these things, and when you open the scope, you can see that it is very much clear that this is my step signal. Once you make this is my step signal, and this is nothing but my ramp signal, or you can go for auto scale also, and you can see when it makes step, in from that point of time it make ramp. So this is the integration of step signal. Clear? Yes or no? Similarly, what is the integration of a ramp signal? So integration of ramp signal is the parabolic signal. Yes or no? Yes. So what you do, you just drag it out here, delete this, and copy this here. Join these two blocks. Why I did this? I know that this is integrator. So integrates step signal, when you integrate it, here I am getting a ramp signal. And here ramp signal already available. When I integrate it, I should get a parabolic signal. And if you run these things and open here, you can clearly visible that this is a parabola. Okay, so now we close these things, and you understood this thing clearly. When I integrate the step signal, I am getting a ramp signal. When I integrate the ramp signal, I am getting a parabolic signal. Okay, what I want to show, I want to take a impulse. So I just take a deep and discrete time impulse signal and connect here. So when I run this, you can see here, this is my impulse. Okay, a small value. I just from 0, it starts from 0 and take 1 and then die out. So it have some length, so it was giving like this, but let's say it is very narrow. Or you can open it and delay time, sample time, it was given 1, and instead of giving 0.005, so that it will be very small. And once you run this, you can see it's a very small signal here. Okay, it's a very small signal starting from 0. You can see the yellow line here. It is not visible actually, but if you try to see, you can see this yellow line here. Okay, it just starts from 0 and again die out. So that if you integrate these things, what you get, integration of impulse should be step. Why it is ramp here? Because I have integrated twice. Here I have integrated one time, here I have integrated two times. So just now what I want to do, I just take it out here. Okay, and I will take it here. Then I just take another integrator here. So I am getting 3 integrator. Okay, so here I am getting impulse, then after integration I am getting step, then after integration I am getting ramp, then after integration I should get a parabola. So I need to find 1, 2, 3 and 4 signal. So what do you do? We just make it 4 channel oscilloscope and click apply, and I am getting 4 channel here. What I do, I just take another line from here and connect to this point, then third line from here connect to this point, and fourth line from here connect to this point. So after doing this, if you click run or simulation, and if you go for scope and open it out, and you can see here clearly that it is a impulse signal, very small impulse, and when the impulse die out, the step starts. Here you couldn't able to visualize the step because the step is starting from 0. So what you do, instead of the discrete, if you increase the discrete time sample to, let's say, 1, so it will be visible to you. And if you go for run, then click here, you can see here. Okay, so this is my step signal, so this is my impulse signal, suddenly die out. So when I impulse is there, it is actually impulse technically, but it look like a step signal. So integration of step is our ramp, so you can see the ramp here. But do not bother about this ramp, just consider this is a impulse signal and nothing is there. So that integration of impulse will be a step signal. You can see here you will get a 1 and continuously go for 1 step. Okay, so integration of step signal is a ramp signal. You can see start from 0 and ramp here. Okay, slope is 1, and when you go integrate this ramp signal, you get a parabola signal. You can see it's a parabola very clearly. You can see it is a parabolic signal. Or if you auto scale this, okay, it will be clear that it's a parabolic signal. Or clear, if you want to see one more time clearly parabolic signal, then you just go for another scope and you just connect this here and go for run, then you can see the parabola clearly. Okay, here this is the parabola. So it is very clear that when you integrate discrete type, when you integrate impulse signal, you will get a step signal. When you integrate step signal, you get a ramp signal. When you integrate ramp signal, what you get? you get a parabolic signal, which I have demonstrated over the screen. Okay,